I hope all of you can hear me. And I'm just scrolling up to the notebook, the top. Okay, cool. So thank you very much for those who have joined for this webinar. And thanks to GDG Mysore for giving me this opportunity. In this webinar, we are going to see how to use a particular package called Plotly Express, which is a Python package to do interactive visualization. So the main objective of this webinar is to show you how basic the API is of Plotly Express, how simple, even to give you a very clickbaity title. So it's every function that every plot that we are going to make is simply going to be a one line. Sometimes due to the length of the line, it could be multiple lines, but it is actually only one single statement of Python. And that statement would give us, as complicated plot like an animation plot. So that is what we are going to build at the end of this webinar. And to start with, about me, I think they've already given a very nice introduction about me. You can find more information. So I also run a similar meetup group called Bangalore R user group, and you can find my articles online, especially related to R and somewhat related to Python. So let's begin, and let's get into the presentation first. If you have any question, I've kept the live chat open on my phone. So if you have any questions, you can post it on it, and I'll try to answer it if I know the answer. Otherwise, I'll just redirect you where you can find the answer. So this is how the presentation is going to be. First, we'll understand why do we actually need interactive visualization. Then we'll have a little bit of understanding about Plotly Express, and then we'll start building basic visualizations one by one. And then we'll see how to take one particular plot and then how to improve it, like one plot at a time. And then finally, we'll see how we can build an entire story with just single line of the code. Okay, so first, why do we need interactive visualization? I think this is the question that a lot of people are still asking. Just let me 1 minute. Sorry. 1 minute. Yes. Okay. So why do we actually need interactive visualization? To demonstrate that, I've actually made a very simple plot. This plot comes from the dataset called car crashes from the Seaborn package. So Seaborn is a wrapper around Matplotlib. For those who are familiar with Python visualization ecosystem, you all know that Matplotlib is one of the most popular Python visualization library, and Seaborn is like a wrapper around it to make a lot of things easier. And so this dataset comes from that, and then we have tried to make a plot. And then the plot is we are trying to plot the state, US state, and we are trying to see the speeding of it. And this is how the plot looks like. So when you look at this plot, you can actually see that how these bars are crammed up. And okay, now I can probably increase the size of the plot and then make it slightly bigger. But still, I don't know what is the value of this particular bar. And then I have to, every time if I want to see it from this, I have to scroll down and see what is the axis here, and still I don't get the exact value. And even if I try to put labels for each and every bar, then it is going to be completely a cluttered plot, because this plot has a lot of bars. And then if I try to label it, then everything is going to be very cluttered. It's not going to give us the entire story that we would like to see. So that is the big problem with a static visualization. Static visualization is still required in a lot of use cases. For example, you could be working for a company where they don't care about anything other than putting a presentation, PowerPoint presentation. So in that case, you just have to simply copy paste your visualization. So in that is a place where you definitely need static visualization. You cannot do anything about it. But there are other instances, like you could be having a dashboard internally, or you could be trying to build a web application, or you could be simply having an HTML file. I'll show you probably after the end of this presentation. This entire presentation is actually available as a HTML presentation. So if you have got a blog, or if you have got something like that, so you can simply export this entire thing, whatever we are making, as an HTML file, and then you can embed it in your own blog, or wherever you want to do. So that is you can actually see that interactive visualization is really handy in these kind of cases where you have got a lot of data points, or at least a lot of categorical values, and you want to make a visualization that can tell the story itself. Now just that we have made the static visualization using Seaborn, we'll see how to do it in Plotly Express. But just to give you a sense, If we do the same thing in Plotly Express, you can actually see that you have the same information. And if you want to see the information, like let's say you want to see for a particular state, let's say NY stands for New York. If you want to see for New York, then you can actually see that you can hover on it, and then you can see what is the information. Okay, the speeding is 3.9, or you want to see for New Jersey, then you can see it is 1.7. So the advantage here is that the plot itself can tell a lot of stories than someone actually having to sit next to the plot and then narrate it. So that is the entire purpose of this interactive visualization. You get a lot of interactivity, there is no doubt in that, but it is a single real estate. So when we say real estate, you have the same space, same viewport on a screen, but using the same real estate, you actually give more information, but without making that information look unpleasant. So that is the entire point of interactive visualization. And you also get to do few other things, like for example, you can particularly pick one particular state. So we were just interested in New York. Let us pick one state, and let's select that particular state. For example, you can go here, and then you can pick one particular state, and then you will get that one state. Okay, I have to, yeah. So you get the point, I think. So now New York has vanished. So if you want to pick one thing, you can select it, and if you want to zoom in a bit, let's say I've got a lot of scattered plot of points. You want to zoom in a bit, you can particularly zoom in. You want to pan it, you can pan it. You want to select, do a lasso selection, you can do. So the idea is it is a single plot, single real estate, but you get to do a lot of things as a user. So let's say most of the data science teams, they actually make something and then they deploy it in some other end that the user has to use it. So in this case, if you're going to deploy it in your stakeholder side, so it could be much easier for them to use this interactive visualization than a static plot and then get more information. So that is the main reason. And I've mentioned few more reasons. First of all, it is very intuitive. Anyone can play with it. It is just like how kids these days operate touch screen phone. It is very much like that. No one has to teach someone like what is in it. Anyone can hover over their mouse and then play with it and then explore it. Again, very less code and more insights. The reason I said very less code is because if you have to add label in a static visualization, you have to add more label related items. But here we did not do anything. It's just a single line, just like how Seaborn visualization is. But we have got most of the information that was required for us. The next thing is customizable. You can select, you can deselect, pan and zoom, all those things. And then finally, the main thing is it's 2020. So I missed a 0 here. So yeah, it's a lot of mobile first things are happening. A lot of companies are trying to make their whatever product they build for this mobile first world. So if you have a plot, it should be compatible, it should be zoomable, it should be easily available for anyone who wants to play with it. So I think we should start using interactive visualization more and more than we use. So about Plotly Express, what is Plotly Express? I think those who are quite familiar with Python ecosystem for visualization, you all know that Plotly is one of the most popular interactive visualization library for Python. There are some alternatives like Bokeh, Altair, but Plotly has been quite popular, especially because they've got a lot of out-of-box code and community has been using it a lot. But Plotly Express is something that they came up with probably, I think, a year or two back. Plotly Express is now a wrapper around Plotly. So you can still use Plotly, but Plotly Express is to make things much simpler. It's a high-level Python visualization library, a wrapper around the exact Plotly. And Plotly Express, just like Plotly, is completely free, which means it comes with MIT license, which means it also allows you to use it for commercial purposes. So let's say you're working as part of a startup, and the startup has visualization. There are many JavaScript libraries would not let you do that. For example, to give you a sense, there is a JavaScript library called HighChart. HighChart lets you use their visualization library only for educational purposes or personal use. You cannot use it for commercial license. So that way, Plotly Express and Plotly also lets you use their JavaScript library, this library that we are using, for commercial purposes. So you can actually sell a visualization product using Plotly Express. And right now it is available only for Python. Then the other thing is, it follows a very simple syntax method, even for complicated charts. And the API is quite inspired by Seaborn and ggplot. So those are from our world. You all know that ggplot, GG stands for Grammar of Graphics, is one of the de facto visualization library in the R world, and a lot of Python libraries have been trying to emulate what ggplot has been doing. So there is a library called Plot9 that does a similar plot like ggplot. So Plotly Express, the makers of Plotly Express, they said that their API is inspired by Seaborn and ggplot, and it is a very consistent API. If you actually see when we start making visualizations, you will get to know that you have a very simple, like you have a data frame, you have x-axis, you have y-axis, and all those kind of things. And if you are from the Plotly world, you would know that in Plotly you have to make Plotly offline every time when you want to make an offline plot. But Plotly Express is offline by default, which means you don't have to explicitly make it offline. You can simply use it offline. So you make a plot, it is available offline. So the other point that I have not mentioned here is that Plotly also has another product, a very good product called Dash. So Dash is let's Dash is okay. I hope Dash opens Dash. Dash is a okay. This is Dash Coin. Dash is a library on top of React and few other libraries, which helps Python users to build dashboards, web applications. So it is, if you are familiar with R Shiny, it is the Shiny equivalent in Python. So Dash is really, really handy. A lot of startups are using Dash to make their own dashboard and visualization on even to sell visualization products. So again, Dash comes with the same license. So the advantage for you is you can easily embed Plotly Express plots within Dash. So that is another good thing because it's all from the same company, same ecosystem. So they work very well together in tandem. Okay. So given that this is the introduction about Plotly Express. So just to summarize a bit, Plotly Express is not a new library altogether. It's just a wrapper around the existing Plotly library, but it is quite high level, which means it has a very simple syntax, and it also follows a very consistent API and offline by default MIT license, and then you can use it wherever you want, even to sell it. So the way you install it is that you do pip install plotly.express. If you have a Mac and then if you have a Python 3, then you can do pip 3. So depending upon how you usually install, you can manage to install it. So it used to be initially plotly underscore express. They released it as a standalone package, but I think now they have integrated it with plotly itself. So you can use it plotly.express. So once you do that and you manage to successfully install it, so just to also add a note, you can load that notebook that I have given in this GitHub link, which was posted by Usha on the group. So you can use that and open it in your Colab also, or you can actually open it on Binder. So it is also available on Binder. You can open it in Binder and then start using it right away. So whatever way is easier for you. If you want to follow this tutorial, play with this, you can do the same thing. So once you are done with that, once you have successfully installed Plotly Express, so the way you can load is import Plotly Express with any alias that you like. So the alias that they are suggesting is PX, and we'll start with the data set that is quite popular with the entire visualization industry, which is Gapminder data set. If you have never heard about Gapminder data set, you should definitely look about Hans Rosling. Hans Rosling has given a TED talk, which is still one of the most popular TED talks he ever given, and he's no more on this planet, but his talk is quite popular. So if you want to look at his visualization or understand about Gapminder dataset, just go to TED and then look for Hans Rosling TED Talk. It'll be really helpful for you to also understand the kind of visualization people make and the kind of interpretation people make. So we are going to load the Gapminder dataset using PX, which is our alias, and from the data and the Gapminder dataset, and we are going to load it. And this is how it looks. So if you can understand this data set, so it has a column called country, it has the respective continent, and it has year. So you can see that for every country, for a given year, they have given you the value. So it is like a value that cumulatively increases. So it is at a given point, this is their life expectancy, this is their population, this is their GDP per capita. These two columns are not required. So if you want to have a look at the tail, mm, let me just load the tail. Sorry. Mm. So usually, yeah. So you can see it is by default it is sorted alphabetically, and you can see that you have the country. It starts from 1952 and it ends at like 2007. And for every country, you have data from this. For you might have some missing values that is there, but mostly you have data from 1952 to 2007. And for every country, you have got a life expectancy, population, and GDP per capita. So this is this data set, and we can start building some basic visualization like basic visualization like so whenever you have a categorical variable and you have also a continuous variable, so what do you usually do? So what we tend to do is we tend to build a bar plot. So because this data is cumulatively increasing data, what we can do is we can take this information only for 2007 starting to see how to build a basic visualization. And if you filter for 2007, I'm saving it in a data frame called Gapminder 7, and you can see how the API is. So the first argument is your data frame, and then you can give X and Y. In this case, I have flipped X and Y because I want a horizontal orientation. But the idea is you give data frame X, Y. So this is the same syntax that it follows for anything that you want to build. So you can see that you have got all the countries. And then the other good thing with interactive visualization library like this is, so if you are making this same plot in Seaborn, let us assume that you are making the same plot in Seaborn. Now your X ticker, this X axis ticker is going to be in some scientific notation like 1E5, 1E10, something like that. But the advantage with this is that it itself optimizes the ticker, and then it gives you the best formatted access. And it also tries to make the font size, everything, optimized for the given real estate. So that is a very important advantage of using any visualization library like this. And you can also see that the thing that we have plotted country and the population. So you should definitely know that there are going to be two big lines, and one is going to be China, and other one is going to be our country, which is India. Yeah, so two big date lines, which is all. So if you want to make some change, like let's say instead of this thing, if you want to make life expectancy, you can just do life expectancy, and you'll get life expectancy loaded. It's loading. Oh yeah, it's a very terrible plot because of the fact that a lot of life expectancy information is, it's not X is not optimized. Then in that case, you can pick a log axis or whatever. But the idea is, if you want to make a bar chart, so you call the alias. Within the alias, you call the function, and your first argument is your data frame. Your second argument is your X, and then you have Y. So you can simply give it without mentioning the parameter names also. But as the Zen of Python says, explicit is always better than implicit. So if you explicitly mention your arguments, it's always a good practice. And so the next plot, that is again, whenever you have a continuous variable, one of the overused plot, and the plot that we use always to look at a distribution is histogram. So you can have a look at it by using simple histogram. So if you see this thing, there is no change other than that you don't need a y-axis. That's it. So you call histogram, you give the data frame, and you give the axis for which you want the histogram to be. And you can see that there are very few countries at the end whose population is high, which is definitely us in China. So that is histogram. And for you to have a look at box plot, so you can see that the box plot looks like this. So you call it with the alias px.box and your data frame, and the continuous variable for which you want to do the box plot. So it's not just you can have only one box plot. You can also define the group, which we will see later. So which means you can have different box plot for different countries. The next thing is, just now, like I mentioned, so box plot is quite helpful for you to understand the distribution, or let's say you want to analyze the macroeconomic factors, and you want to find out how certain countries, within a country, how the information is varying. For example, if you take employee salary, the difference between a the salary of let's say a security guard and an employee and a CEO would be like very different. So that distribution is like going to have a very long tail, and it's going to be very the range is going to be huge, right? So for you to identify those things, it is also better if you actually group it. If you group the box plot by some categorical variable and then you make different boxes. So that's what we are doing here in this case, that we have grouped the box plot by continent. So now you can have a look at saying that for a given continent, how the life expectancy. So when you actually see life expectancy, you are around here. Our median is, if you see, it's 60. But if you, when you group it, you actually can see that how some countries, for example, if you see Africa, whose um, uh, whose GDP would not be really great of the fact that we know. So you can see that Africa's median life expectancy is only 47, but your entire median is 60. So you can actually see that now how these things vary between different continents, and you can do it for different countries also. But because we have got a lot of countries, then this plot would be cluttered. So if you want to do it for different countries, then you can probably filter it for different country, and then you can plot it like that. So this is a box plot, and the same syntax. The next plot that we are going to see is a violin plot, which is almost like one of the most favorite for a lot of Python users. A violin plot, if you are familiar with a violin plot is nothing but like a box plot, but with a density distribution at the border. So rather than having just the box, you also have a distribution. So you can imagine it is like a histogram with a density plot. How you plot a histogram with density plot. This is like a box plot with a kernel density. So now you can also see how the distribution, like how wide it is, how narrow it is. So you can see all this information. So if you see Europe, you can actually see how it is like quite wide. So, but we are not here to discuss visualization logics. But the main point that I wanted to highlight here is you just take this box plot and then you just call it violin here. It will become a violin plot. So that is what we mean by a very consistent and simple API, where you don't have to make a lot of changes, because once when you are in the flow of doing EDA, it is very important for you to iterate or prototype very faster. You don't want to change heck lot of things, do 10 different things. So you want something that is like quite faster for you to iterate, and that is what they call as rapid prototyping, right? So you should have that ability, and Plotly Express is quite handy in that, giving you that ability. And finally, when you have one categorical and one continuous variable, but when you have it over a period of time, so then the best plot that you want to make is a line chart. So in this part, we are seeing so leave this part. This the first argument is I'm trying to take the data frame here itself. So just to avoid the number of countries that we want to have. So I could have simply used this, but I'm just trying to do that. So don't think this plot is complicated. This is just the data frame part, and then you have your x-axis, and then you have your y-axis. You can see your x-axis, and then you have got your y-axis, which is your population, and then you have country. So if you want something else, you can change life expectancy. Let's hope I didn't make a mistake with the parameter name. And color is country to say what different countries, so you can get the legend. So you can see how the life expectancy has changed. So you can see, probably, I don't know whether there was some kind of famine or disease. Kenya around this time, life expectancy has dropped. So how it is consistently low, and then if you see for country like China and India, how it is different. And for United States, you can see life expectancy is always on the top. So like we discussed initially, now if you want to select a given plot, you can just pick one and then double click. Okay, and you can pick the particular country that you like. So now you can select Kenya only. If you want United States, you can select only United States. So like that, you can do that. And it's not just only you. So wherever you are deploying this plot, that person also has this ability to do that. So now that we have understood how to make some basic visualization, like let's say box plot, violin plot, histogram, or bar plot. So the next thing is for us to pick one particular plot and then see how to improve that plot, because it is not entirely difficult for someone to make a basic plot, but it is slightly a complicated task to improve that plot, to have more stories and more important information. So for that, what we have picked is a scatter plot. So when you have two continuous variable, so the plot that mostly we do is scatter plot to understand the relationship between the continuous variables, to see how the distribution is. So, so in this case, we have taken our GDP per capita and also our life expectancy. And then as you can see, the syntax stays same. So your API is very consistent in this case. Again, so you call scatter, and then you have your data frame and your x-axis and y-axis. Now you can see that there are places your GDP per capita increases, and this is, but most of the GDP per capita, if you see, it is all within here, like within 40,000 or something. And just like I mentioned before, now you can see that your x-axis is formatted, and every time you make it, your x-axis is formatted. Before that, we had something related to billion, and now we have something related, something with k values, which means again, the advantage is you don't have to manually fix your ticker formation, formatting. It itself does it for you. So now that we have made this plot, if you want to cram up more information like how the disk plot on Python is for Seaborn, you can still have a distribution here in your x-axis or y-axis, which is not very meaningful in a lot of cases. But if you want to add that information also, you can do that to see, okay, this is how my GDP per capita distribution is. This is how my box plot is. Or maybe I don't want box plot for, I don't want histogram for x-axis or y-axis. If you want histogram in both the places, we can say, okay, histogram. So other than the three parameters that we had initially, data frame, X, Y, now we have added two more new parameters to say that what is my marginal Y, what is this part, and what is this part, and what kind of plot I want there. So that is how we are cramming up these things. And another practice that a lot of people do while doing EDA is whenever you make a scatter plot, you also tend to fit a line. So in this case, we are trying to fit a ordinary Lilly square line, OLS line, to see that how the trend looks like. Maybe this is not a very good way of doing it, because now before you do this thing, you have to deal with outliers, you have to remove it. But just for the sake of educational purpose, how to fit a trend line, it is not complicated. Within the same scatter plot, you just have to say that, okay, my trend line, I want wireless. That's it. You don't have to do anything complicated. You just have to add one more argument with the value, the kind of trend line that you want, and wireless gives you the trend line that you have. So this is how the trend is going to look like. So like I just mentioned, R square is very terrible. You have to definitely do data cleaning before fitting a trend line. But just to see how simple it is to fit a trend line with a scatter plot. The next thing is, whenever you are looking at this, let's say information, you're getting life expectancy, you're getting GDP per capita, but that is not entirely useful, right? So, like, what do I make out of this thing? Okay, GDP per capita is high, life expectancy is high, but do I know which country is this thing? So that is what we're going to do in the next section, which is to say, okay, I want, when someone hovers on, I want to show the country name. So that is again simple to say that, okay, hover name is the variable, is the argument name, and I can just say what hover name I want. So when I say country here, whenever I hover it, I'm going to see, oh, Japan it is, oh, this is Norway, and this is Singapore, Kuwait. So you can understand that how we took a simple scatter plot that looked very simple like this initially, and how we started customizing the scatter plot, either to add some marginal plots, or to fit a trend line, or to even customize the hover value just with only one extra argument. So now that we have done these things, let us try to see few more things. For example, now that we have this plot, we know the country name, but we cannot easily find out, okay, which continent it is, or can we make some insight to say that, okay, this area is all particular given continent, this area is all particular given continent, and that is where we want to use the variable color to say that I want to group this plot based on the color. So I'm going to have color variable. So for time being, I'm going to remove this log x-axis, which I'll explain why later. Okay. So let's run this plot without log transformation, and then we'll have some idea about why do we have to do log transformation. Okay. So now when you actually see this plot, you can see that, okay, wherever you have very less life expectancy and very less GDP per capita, you can actually see green color, which is African countries, and you can see European countries scattered all over it. And then again, you can see two countries, which is Australia and New Zealand over here. And then you can also see which one is top and what continent it belongs to. So it is really, really handy for you to see Africa is here, Asia is predominantly here, Europe is somewhat here, and then you have Americas somewhere around this area. So this way it is quite handy. But the problem in this plot is, if you see this plot, all the data points are almost cluttered, almost cramped up here. So what we can actually do is, this is where, if you see, your access is incrementing by 10,000, 10,000, 20,000, 30,000, 40,000, 50,000. And this is where it makes a good sense to use something called a log transformation, because when you use log transformation, you will actually see a huge change in the way you can interpret plot. So the way you can do log transformation is simply log x is equal to 2. So now we are making x-axis with log transformation. So unlike in a lot of visualization libraries, you don't have to now go back to your data, change the data, like make a log there and then come back and plot. So here you just have to add one more argument, and now you can see the axis is different. And this is something that you should actually look into whenever you see a lot of plots in the press or media. So this is how actually people cheat in a lot of cases. So they tend to show countries. Now you may not feel bad that much for Africa, because you're like, oh, Africa is here, but you see America is also here. So, but in reality, if you see the axis, it is 1,000 and it is then 10,000. So the axis is not equally placed, but it is like logarithmically divided. But it is still important for you to have better visualization of how the plot looks like, rather than all the data points being crammed up in only one locality. So even within this, you can actually see the difference between different African countries. So like, okay, South Africa is here, whose GDP per capita is high, but still their life expectancy is low. But in this plot, if you had to, without log access, it would have been slightly difficult for you to find it out. So log access, doing log transformation in either your x-axis or y-axis, where the data points are crammed up, is a really, really good technique whenever you are doing EDA to find out relationships. So until this point, what we have done is, we have tried to see basics of plotly, how to build basic charts. Then we have taken one scatter plot, and then we have tried to improve that scatter plot with more information. So when we started, the scatter plot looked like that. It didn't have much information. Like, it didn't tell me which country is this. It didn't tell me anything at all. It just told me that, okay, good, there is some relationship between GDP per capita, because this goes like that, but I don't have trend line. I don't understand whether this relationship is equally applicable for every continent. I don't have any of those things. And that is what we did step by step. We started adding few things, like we started adding a trend line. We started adding the hover value, and then we also grouped it by country, and then we also did a log transformation of our x-axis to see how the plot looks like. So with this, we have almost concluded 90% of our presentation, to say that, okay, so now we have a plot. We took a basic plot, we improved all the data points, and then we have got a slightly beautiful and more information, a plot with more information. So the next thing is, we are trying to build a story with only one line. So our idea is to take a plot, but that will have only one line, just like whatever we saw before, and then that will have all this information that we wanted to see. So to see what it is, so you can see that we are taking the same scatter plot again, and we have the same information, that plot, but we have not grouped it. But what we are trying to do is, we are trying to facet it. And this is again another important thing, because when we fit trend line, the trend line is going to be same for the entire data points. But here in this case, we can actually see, okay, so for Asia, it looks like it is more like the relationship is more, but for other African continent, you can see that sometimes it is quite slightly flat, and then it increases. So this way you can actually see different trend line for different continent or group categorical variable. So the way you do facet is simply you have to just add facet underscore column with continent. So if you see the difference between this plot and this plot is simply one extra argument that says facet column is continent, which means you're expecting the plot to give you a faceted plot based on the continent value. That is done. And the next one is, So you have got a scatter plot, and the maximum amount of information that you can put it inside a scatter plot that we have seen so far is maybe we can put a trend line, maybe we can have a hover value. But let's say, what if you want to add one more continuous variable to a scatter plot? So how do you do that? So the way you do it is you make a scatter plot into a bubble chart. And what do I mean by that? This now, if you see this dot, the point is all of same size, so it doesn't signify anything. So either you have a point, a tick mark, or whatever symbol you have there, it is not going to make a difference. So what you can do it is to convert a scatter plot into a bubble chart. So now you can start giving a continuous variable to this particular point, so that the point size, the size of the point, becomes another new variable. And that is what we are doing here, which is to say that we took the same thing, the same scatter plot that we had before. Okay, so the same scatter plot, and what we are trying to do here is we are trying to say, okay, now the size of this point is going to be the population. So this way you can have some idea about, okay, this is a country which is Nigeria, which has a lot of population, and this is their GDP per capita, and this is most probably, yeah, China, and this should be us. Yeah. So these are, like, now you get better sense. You try to understand how population is playing with this thing, how population is getting into this thing. And that is, again, you don't have a separate function for bubble chart. You use the same scatter plot, but you add one more argument called size, and then you give the column name that you want to do, and you can change it with anything you want. For example, your y-axis could be population, and then your life expectancy could be your size. So you can do anything that you want, the way it can tell you better story. So that is the main thing. So the idea is you want better story, and it is not giving you better story because life expectancy doesn't vary a lot. So if you put life expectancy as your chart bubble size, it doesn't change a lot. The smallest is like this, the largest is like this. So it's always good to play with the plot and then see which one is helping you to have better visualization or better story. So you can do the same thing, even bubble chart with facet with continent. It is the same syntax. And then within that, you can also define hover values. So you can say, okay, when I hover, I want the country name. So here in this plot, okay, it's still getting created. So in this plot, okay, just go to the next one. It is still creating. So it is just you have the bubble chart. Okay, this is not a bubble chart. You just have a scatter plot with country values and hover. And if you want a bubble chart, you just have to add size over here. So the main final thing is, which I wanted to show is, which is, okay, 1 minute. Let me just load it before I start explaining. So the main thing that I wanted to show ultimately is how we can make an animation chart, which is what if you see the TED talk of Hans Rosling, he would have shown how you can make the same plot, which is really not a simple plot. So to give you a sense how animation is made, especially GIF kind of animation is made, is you take multiple frames. So of a plot, you take multiple frames, and those frames vary based on something. So in this case, if you want to make an animation plot for time period, so the frame value should change for every given time period, and then you take screenshot or you take frames of all these individual things. Now you stitch, or in animation they call it tweening. So you stitch it together, and then you run it based on a time period, you like a speed. That is what you call as FPS, frames per second. So this entire process is not really a simple process. It takes quite a bit of effort. But the greatest thing with Plotly Express is, again, this entire thing you can actually do it in one single line of Python code. And when I say one single line, I'm trying to mean the statement, not the actual line number. So until now, what you saw here is our plot is the same. So you have so instead of Gapminder 7, I'm going to use the entire Gapminder because we want the time variable also, right? We want the plot to differ for time. So I'm going to say my x-axis is GDP per capita, which is the same. My y-axis is life expectancy. which is the same. And the other only two extra thing that I'm going to add to make this entire plot an animation plot is I'm simply saying that my animation frame should vary for every year. So like just like how we discussed now, you take a plot, you make a plot. Let's say you make a plot for let's see what is the first year in this. Okay, you make a plot for 1952, you take a screenshot of it. You make a plot for 1957, you take a screenshot of it. You make a plot for 1962, you take a screenshot of it. You make plots like this, and then you tween them together, and then you play them. That's how animation is made. So we are saying that our animation frame is year, animation group we have grouped it by country, and then we are saying that our bubble charts size is population, the value in it, and we have colored the country, and then when you hover you want the country. Very few changes that we have done with respect to access is we are saying that maximum size I want is only 45 of the chart, and we are also optimizing this X range to say that I want till 100,000. So I want to start from 100 to 100,000 rather than just using it from zero to like something that the plot usually does. So we're trying to customize so that the plot looks better, like it doesn't end. So the same way you are saying that my x-axis I want from 25 to 90. This is something that you can play with in a lot of visualization library. It is usually known as x limit and y limit. So in this case, it is called as range x and range y. So once you have that thing, now your plot is ready, and then you can simply go play it. So let's see how does it look when we play it. Okay. So you can see how the plot changes. So this would be slightly smoother than how it looks like now. It's probably because I'm streaming from the same browser window, and also I'm showing this plot. And JavaScript, it's a heavy JavaScript activity happening behind, so you can see. So the main point in this is you can actually see how a given country's population is changing over a period of time, and how it is also changing with respect to, for example, if you want to look at this plot, you should look at a particular data point. So if you want to understand, let's take some country, let's take Poland in this case, or let's say Iran. Okay, Iran is a very bad example in this case. mm, let's take let's take Nigeria. So Nigeria is here when the animation starts. Okay, it shouldn't be here. It's 2007. I'll just drag it back. Okay, where is Nigeria? What is visible here? Okay, let's see Mexico. Just pay attention to this one particular data point and see how it changes when the animation goes. So that is the real story that you can get out of it. So you can see that Mexico, it is growing their GDP. Oh, sorry, their GDP per capita is increasing, and then Mexico is growing, and then I think this is Mexico. See, Mexico has reached here. So the size has increased, and their GDP per capita has increased. And while that has happened, their life expectancy also has increased. So it was initially here, it has gone here. So this way, you can make one plot, and then it is quite intuitive for you to tell some lesson. And if you want to pick some particular country and then make this plot also, you can do that. But the better thing is to have this entire thing, and then you can play with that. So if you want to just check once again, we'll just quickly look at one more country to understand how to actually tell a story out of it. So I think, what is this country? Oh, it's very small. Let's say this is Germany. This green color is Germany, which is already doing great. Okay, let's take the South Africa. So South Africa in 1952, their life expectancy is 45, and this is their size. This particular plot, and I can actually zoom it a bit. Okay, so this is South Africa. Let's see how South Africa changes. So I've played the animation. So you can actually see that South Africa is growing. South Africa is growing. South Africa, in fact, went out of our window. Nice. The plot is still coming out. So when you zoom out, zoom out. So you can see South Africa has grown up, like improved in both GDP per capita and life expectancy. And this is the main important thing with visualization is, see, not every time you need animation. That is definitely sure. Unless until you want to get more likes on your social media, like LinkedIn, Twitter, you can make animation plot and post it. And in fact, I'm not actually kidding. So there are many channels on YouTube that just simply posts animation of charts, and they've got like thousands and thousands of subscribers. So that actually gets more eyeballs. There is no doubt in that. But in a corporate setup, if you're working in a company, not every time you need animation, but there are many cases. Let's say you are working in a sales and marketing department, like part of the data science team, and then you want to showcase how their revenue has grown over the year with respect to a continuous categorical variable. And then this is a really intuitive way for you to do that, and it is quite simple. You can now use any desktop. You don't even have to play it every time. You can use any desktop video capturing device, like software. And if you use Mac, QuickTime Player is quite handy. If you use Windows has game center recording, so you can simply use it and record it and then keep that playing wherever you want to show. So that way, in just with no effort, in fact, for that matter, you just added extra two parameters to the actual plot that you are building until now, and then within that you have successfully made an animation plot. So there is no learning curve at all, but still you can go through the documentation, learn a lot. But the idea is how simple it is to take one simple scatter plot and then just keep on adding few more attributes, arguments to it in the form of arguments, and then make that scatter plot into such a nice story that was popularized by Hans Rosling. You should definitely look at the TED talk if you have never seen it. So this is to show that how Plotly Express makes it quite simpler for you to recreate Hans Rosling's Gapminder animation. So I think that is all I've got. Yeah, that is all I've got. So I hope this presentation was useful. And if you have any feedback, you can just mention me on Twitter and then let me know this the feedback and what do you think about this particular library. We'll just see for a couple of minutes if you have any question on the YouTube channel. So I don't see any question on the YouTube channel so far. So is there anyone going to post a question? I think if no one has any question, we should probably wind it up. I'll ask Usha. Should we wind it up, Usha? I think no one has any question. So if you have any question, you can just reach out to me either on this Twitter handle or you just put my name on Google. Google is going to give you all sorts of ways to reach out to me. It's very easy for you to reach out to me. And thank you so much for joining this presentation. And I hope it was useful. And I hope you are also going to start using Plotly Express going forward. So thanks again. I'll stop sharing and yeah, have a nice, safe, healthy weekend. See you. Bye bye.